A jumbo jet that flies with the hatch open. The biggest research aircraft in the world. The Beast, the biggest snow groomer serving the best skiers. The mountain climber of trains. This cog railway tackles the world's steepest route. This is no normal airplane, but rather the biggest airborne observatory in the world, in the hull of a Boeing 747.
It's absolutely a privilege to be here and do this.
There's only one SOFIA in the world. There's no replacement.
SOFIA is an acronym for Stratospheric Observatory for Infrared Astronomy. Its objective: to study star-forming regions, planets, comets, and interstellar medium on the basis of the infrared rays they radiate. US, NASA's Neil Armstrong Flight Research Center in California, on the edge of the Mojave Desert. Until the maiden flight of the A380, the 747 was the biggest passenger aircraft in the world. The raised nose and the bulging cockpit make the jumbo jet one of the few airplanes whose silhouette is immediately recognizable. SOFIA is a project of NASA and the German Aerospace Center. Engineer Oliver Zeiler checks the core element before every mission: the infrared telescope. He does this in the command central, the former passenger cabin. The tail contains the telescope's mechanical system, which compensates for the plane's movements.
It's very different from flying with a normal plane. If something goes wrong on board with the telescope, you feel a little pressure and some tingling trying to fix it as fast as possible. But it's fun.
All right, welcome to Flight 391. Takeoff at 2028.
The weather is always important, as it influences the telescope's accuracy during the flight.
Two areas of issue right now: the British Columbia, almost the entire British Columbia. A lot of turbulence been reported today.
If it is too strong, the telescope stops working. Shortly before takeoff, flight engineer Moose Pier performs his final check.
Pre-flight inspection, we just basically make sure the aircraft's ready for flight. No panels missing, tires are in good condition. When maintenance turns the aircraft over to ops, we take responsibility for that.
40 minutes before takeoff, the pilot, scientists, and engineers are on board. Now for something everyone is familiar with before a flight: the safety instructions. In the meantime, Moose Pier and the pilots prepare the 747 for takeoff.
Are you guys ready for start down there?
Ready for engine start.
Thank you.
Ground, this is pilot. You guys ready to start down there?
We're ready for you to start wherever you are.
Okay, we'll start 2 and 3.
As opposed to a standard passenger aircraft, SOFIA takes an extremely long starting run. The idea is to go easy on the fragile devices on board, especially the 17-ton telescope in the tail. After takeoff, the pilots give steady full thrust to gain altitude as fast as possible. The goal: to maximize observation time for the scientists. Tonight, they plan to examine the composition of the atmosphere of various stars. Missions like this take place exclusively at night. The telescope cannot be used during the day.
This mirror has a diameter of 2.5 meters, a parabolic mirror. When sunlight hits it, it naturally focuses the light on a point. And this point, in the posterior cavity where the telescope is, gets very, very hot. It can reach several hundred up to 1,000 degrees. And that would be dangerous for the plane.
In addition to flying at night, altitude is also crucial for studying the universe.
We do operate them higher than most airlines would like to. And the whole reason for that is the higher you get, the less atmospheric moisture is. Moisture is one of the things that obscure the science observation. So the higher you get, less moisture equals better science.
The aircraft reaches an altitude of 10,700 meters, perfect for opening the door to the telescope.
And should be moving. Door moving.
And now, the unbelievable happens. A huge hole opens on the side of the 747. Every passenger's nightmare. But this time, it's on purpose. And at a speed of about 1,000 kilometers per hour.
When the door opens, you don't hear it or feel it. The pilots don't feel it in the airplane's trim. You don't really even notice it at all.
There's a fairing back there that creates the airflow to not get in the telescope assembly, so it's a pretty brilliant design.
SOFIA is at the forefront of technology. It was designed and built over a period of 20 years. Today, project leader Eddie Zavala is in charge of this unique plane.
When you first see SOFIA, many people tell me that their first reaction is, wow, this is a big airplane. And it truly is. It is the world's largest airborne observatory.
SOFIA's basic frame is a modified Boeing 747. The idea was to combine the biggest airplane of the day with the biggest possible infrared telescope. The aircraft was disassembled into 3 pieces and then put back together by the same company that builds Air Force One for the American president.
There were a lot of engineering challenges, primarily, first of all, putting a 17 metric ton telescope with a 2.5 meter primary mirror in the back part of the airplane with a door that opens up without causing aeroacoustic resonance. If we had had acoustic resonance when we opened the door, SOFIA would sound like a train whistle as the airplane is flying at 500 knots.
Another challenge. The big telescope makes the airplane tail heavy. Thus, a counterweight is provided by tungsten plates under the cockpit. The scientists are observing objects in the night sky that are light years away. The telescope always maintains the same position, compensating for the airplane's movements and turbulence.
Right now, as you feel this little light turbulence, this little chop, the telescope assembly is stabilized, and it's kind of like a rigid in space. It's almost like a flying gyro.
But today, the telescope is taken to its limits. The turbulence is too strong, and the telescope no longer responds to computer commands. A mad rush at mission control on board. The problem is quickly found. There's no electricity.
What are you proposing for a solution here? Just what? Taking everything down like you originally planned. All right, so we've got one shot to reboot that to reset that's the circuit, right?
Rebooting the system. A big problem, a simple solution, but not simple for a priceless plane while still in the air.
There's a mission rule on board. When a circuit breaker trips, you can reset it once and continue. But if it trips again, then it is clear that there is a problem somewhere in the device, and then you can't keep trying to reset it 2 or 3 times. And you either have to keep this system turned off, or the mission is over.
A catastrophe for the scientists. They often work on their research for years and have only this one moment to test their theories. Thus, Oliver Zeiler and the engineers on board must resolve the problem as fast as possible.
Now I feel better. We resolved everything and the scientists are happy again. We're observing again, collecting data. Yes, now it's working again.
The telescope and the computer are working again, according to plan. The mission has been salvaged and much money saved. The flight's kerosene alone costs 80,000 euros. Oliver Zeiler and his engineering team make sure that the telescope performs dependably. The airplane itself is constantly being checked by Moose Pier. It fascinates the flight engineer as much as it did on his first day.
It was kind of overwhelming that, you know, you can take something that is such a modification and actually get it airborne. And you think about all the coordination and the teamwork that takes place to make every mission work is fascinating every time you fly.
SOFIA's research missions are planned until 2030. What happens after that is unclear. Until then, The 747, operated by NASA and the German Aerospace Center, remains the only and the biggest airborne observatory in the world, and a true ultimate vehicle. This vehicle goes by the name of Beast. The Beast is the biggest and most powerful snow groomer ever. Schladming, Austria, the Beast's territory, the biggest, steepest and most challenging ski areas on the planet. In a few days, Schladming will host the night race, one of the most difficult World Cup slalom races. Today, the Beast is grooming the piste for this important event. Chief driver Wolfgang Perhab himself is at the controls.
Today is very special. We're preparing for the night race, for the best of the best. The piste should be perfect. So, we're taking care of it today, making it the best we can.
The cable winch prevents the Beast from slipping and thereby damaging the ground below with its weight of 15 tons. Hooked up to its little brother, the Beast starts off. Wolfgang Perhab's first job is to bring the snow back up the mountain that the previous day's skiers have pushed down into the valley.
The important thing is not only to flatten out the piste, but to give it contours. They shouldn't be steep or too angular. They should be harmonious. A challenge, but not a danger to the skier.
Then there's the time pressure. By this evening, the entire piste, 300 meters long and 50 meters wide, must be finished. Track for track, Wolfgang Perhab pushes the snow into position. With just one joystick, he controls all the functions, including the snow blade, the winch, and steering. Thus, he can maneuver the huge snow groomer with only one hand, and at the same time, take care of race preparations.
The blade is extra wide, just like the groomer itself. Its great advantage is that it has lots of space for pushing snow.
The Beast can push 8.5 cubic meters of snow at once.
My first thought was, it works great. Finally, real horsepower. We used to have 300 horsepower. Now we suddenly have 527. And that's great for a driver. He can fill up the blade and not have to worry about how he'll make it up the hill.
The snow groomer moves up the 52% grade slope at 10 kilometers an hour. The Beast is built in Sterzing in South Tyrol. In the 1960s, the engineer and race driver Ernst Prunot developed the world's first ever serially produced snow groomer in a car repair shop. Today, his company is one of the 2 market leaders for groomers. Engineer Martin Kirschmeier was one of the leading minds involved in designing the Beast.
Weight is always important to us. We don't want to be too heavy as we've got to drive up the mountain at a high speed. So we had to find a compromise between size, performance, and what could realistically be used on the piste. And that's how we arrived at the Beast's dimensions.
In comparison, the world's first serially produced snow groomer looks rather small. In the years that followed, ski areas got bigger and so did the groomers, ultimately resulting in the Beast. Its dimensions also pose some challenges for the experienced snow groomers engineers, as Martin Kirschmeier recalls.
The challenge of developing such a large groomer is not only that everything must be larger, but that you have to consider every detail, every small part. Is it still strong enough for the new stresses resulting from the blade's larger size? The vehicle has more power.
To this end, the Beast has a 527 horsepower diesel engine, the kind usually used in cranes and diggers.
When the Beast was started the first time and had its performance tested in the lab and the horsepower was there and we saw that it worked, it was a great feeling for us. We saw, hey, awesome, this is working, and we can use this on the snow and we can keep going in this direction.
After a good 3 years of development, the Beast was presented to the public in 2009. It is now used in 75 ski areas. In Schladming, Wolfgang Perhab, the driver, is in the midst of preparations for the upcoming World Cup slalom race.
We're done pushing the snow. Now it's time to start with the detailed work of tilling. It looks good for the best of the best.
His most important tool for this, a tiller 7 meters and 10 centimeters wide.
It has many teeth, and it's important that they are all intact and that we go very slowly and with high rotation speed so that the tiller really does its job.
This step is extremely important. Only tilling stabilizes the piste. Rotating 1,500 times per minute, the tiller shreds the snow grains. This way, they can melt together to make a stable snow mantle.
The advantage is that this tiller now gives us 7 meters of width, so you don't have to go back and forth as many times on a large area.
2 hours later, as night falls, the job is done. Wolfgang Perhab is satisfied.
The piste is perfect, thanks to the Beast's width and speed.
The night race can begin. It is the steepest cog railway in the world, the Pilatus Railway. Thanks to its unique cogwheel system, it handles grades no other train could. The Swiss Alps. The Pilatus rises to a height of over 2,100 meters. Christian Müller prepares for a test drive. In 2 days, the railway is scheduled to reopen after the winter break.
We're checking the engines, making sure they don't overheat, and then the 3 brake systems.
The so-called power car is train and locomotive all in one. A locomotive trailed by cars would be too heavy to make it up the extreme grade. There is room for up to 40 passengers in this special cog train. Then Christian Müller starts the 210 horsepower electric engine. An 18-gear transmission transfers the engine's power to the cogwheels. The many gears ensure an optimal transmission on the demanding route. The rails are original to 1888. Before the season opens, they are thoroughly inspected. An arduous task on the steep slope.
The tracks are free. We can go.
Christian Müller always keeps an eye on the tracks.
Driving up, we have to make sure the tracks are free and the overhead wires are clear of branches.
Like the cars, the overhead line is also from 1936, when the railway was electrified.
This is the first 48% grade. This is the first of 3 such sections.
A 48% grade, almost twice as steep as every other stretch of railway in the world. The car is also specially designed for this demanding route. Much effort was put into keeping the construction light. On a 48% grade, every kilogram counts. After about 15 minutes, the train reaches the halfway station at an altitude of nearly 1,400 meters. The driver, Christian Müller, performs his first inspection. All of the machinery is underneath the car. That makes maintenance easier and creates more space for passengers.
Everything looks good. Temperature's right, not too hot, no wear. Oil, engine, gearbox, it's all good.
The cars were built at the Winterthur Locomotive and Machine Works, meanwhile bought up by Stadler Rail, one of the largest train manufacturers in the world. Urs Wieser worked at the Winterthur Locomotive Works and is responsible for cog railways at Stadler Rail, and thus also for the Pilatus Railway.
The Pilatus in Lucerne, on the other side, Mount Rigi. Getting up there was very attractive for tourism at the time. The Pilatus was much steeper, so something new had to be designed. Cable cars didn't exist yet, so it was an exciting task to build a railway up there.
The Pilatus Railway's first cars were driven by steam. They brought nearly 50,000 passengers a year to the summit, an unexpected success. To increase capacity and meet the heavy demand, the railway was electrified in 1936 for over 1 million Swiss francs. It also received the new power cars, which are still used today. In the first year alone, these cars brought more than 100,000 people up the Pilatus. Even today, the Swiss train manufacturer regularly sells new cog trains. In contrast to the Pilatus Railway, however, they have only one cogwheel. The system with two cogwheels remained one of a kind, despite its success.
It's an incredible accomplishment. All the things railway engineers invented in the late 19th century. Reckoning by hand, drawing by hand, everything done on paper with a ruler, no resources like we have today. No CAD, no calculation programs, and they had no test tracks. Only when the first train drove did you know if it worked or not.
The engineers who built the Pilatus Railway did everything right. Christian Müller, the driver, has meanwhile almost completed his test drive.
The railway is good. It's 80 years old now, and we're proud it's so dependable. There are few malfunctions or breakdowns. We're proud it runs so well and never lets us down.
Only about 5 minutes until the summit. But then...
Sadly, this is the end of the line. I thought my colleagues had cleared more snow, but there's snow on the tracks ahead. They needed more time than I thought, so we have to go back.
The masses of snow up here at about 2,000 meters are also the reason why the railway only operates in the summer. For the return journey, Christian Müller moves to the second cab. It's there because the car cannot turn around on the tracks. For safety reasons, the train descends at a maximum of only 9 kilometers per hour. If it exceeds this speed, an automatic brake engages and stops the car, an important safety system. Christian Müller tests this brake now to end the test drive.
We stopped moving almost immediately. That's good.
In the next 6 to 7 months, the steepest cog railway in the world will bring more than 500,000 people to the summit of the Pilatus. The MiG-29 is for many still the best dogfighting jet in the world. A ship with aircraft propulsion, this catamaran holds the title of fastest commercial ship in the world. And finally, Of all conventional high-speed trains, it has the most modern drive system, the ICE-4. Argentina, Buenos Aires. Aircraft turbines turn this large catamaran into a true speedboat.
My job is unique. Perhaps it's like that of a Formula One driver.
We're talking about the fastest commercial passenger ship in the world, the HSC Francisco. She accommodates 150 cars and just over 1,000 passengers, and still reaches record speeds. Puerto Madero, Argentina's biggest port, indeed one of the biggest in Latin America, and home to the world's fastest passenger ship, the HSC Francisco. The hull, a 100-meter-long catamaran constructed of light aluminium. The ship is a masterpiece combining all the tested technologies of speedboat building. 2 aircraft turbines supply enormous power. Fully loaded, the ship can still reach a high speed of 52 knots. A total of 3 decks provide space for engines, cargo, passengers, and crew. Every day, the ferry shuttles twice between Buenos Aires in Argentina and Montevideo in Uruguay. The first ship leaves the Argentine capital at daybreak. Boarding, loading, and engine check take place simultaneously in only 1 hour. The most important man on board, Captain Nico Strasser. He has been guiding the ferry between the Latin American capitals for 3 years. His job is more than mere work to him.
I feel very good. Being captain is a great satisfaction. This ship's technology is different from others. It's brand new.
The crew carries out the engine check with the onboard computer. Each tiny sensor can be monitored and controlled from here.
The ship is technologically complex, especially the gas turbine drive. Small problems always crop up.
The trickiest moment, refueling. The HSC Francisco's main fuel is liquefied natural gas. She is the first ferry in the world with natural gas propulsion. While the crew refuels, no electronic devices may be nearby. There is a great danger of explosion. 10 minutes before the high-speed ferry departs, the captain gives the signal to start the engines. The turbines need this long to reach their full power. The crossing to Montevideo, Uruguay, 190 kilometers away, lasts 2 hours and 15 minutes. Across from the HSC Francisco's berth, a fleet of maintenance engineers works. Among them, Gerardo Babini. He was part of the building team in Tasmania and knows the ship better than just about anyone.
The secret of this ship is the relationship between its power and weight. The Francisco has 2 22-megawatt turbines, and that's how the ship reaches such high speed. So, the turbines have an advantage. They have a lot of power for such a light vessel. Like with airplanes. They are aircraft turbines, after all.
The greatest challenge for the engineers was not during construction, however.
Getting from Tasmania to Rio de la Plata was so hard. The fuel tank capacity was too small for the Pacific crossing. So, we stowed 8 additional balloons with 25,000 liters of diesel in the cargo hold. That's how we made it across the Pacific. Very difficult.
Difficult because the catamaran is built for shallow water with few waves, not for a journey across the 7 seas. Meanwhile, the turbines have warmed up. The voyage from Argentina to Uruguay along the La Plata River can begin. The turbines bring the ship to a speed of over 50 knots, gulping down a hefty amount of fuel in the process. But since the ship is powered by natural gas, the high-speed catamaran is also one of the world's most ecologically friendly ferry.
The biggest risks are launch and landfall, like in an airplane.
The passenger ship is named for the Argentine Pope Francis. Guests travel comfortably in 3 different classes. And they have the opportunity to shop in the largest duty-free store ever built on a ferry. Tickets for the trip to Montevideo start at $100. The passenger ship takes a good 2 hours to travel to Montevideo.
Hello, this is Francisco. We're arriving in the harbor.
Captain Nico Strasser turns off the autopilot and guides the ferry manually into the harbor, using only 5% of the ship's total power. The maneuver requires the entire crew's absolute concentration. The smallest steering error can result in a harrowing accident.
The greatest danger is ramming the harbor wall. That's why we go at the lowest speed possible. Captains must complete a 3-month training course here to master the landing maneuver. Ultimately, experience brings a sense of security.
The ship did ram the wall in Montevideo once. That totally destroyed the catamaran's front blade. Today, the captain guides the ship safely into the harbor.
Very well. That's finished. Sometimes it's like very stressful when it's really windy and dangerous, and then you're like, okay, we do it. But no, normally it's just routine.
In Montevideo, a smooth transfer takes place. While the passengers and Captain Nico Strasser leave the ship, the next crew prepares for the return journey with a high-speed catamaran. Hamburg, Germany. The ICE-4. With nearly 13,500 horsepower, it is the most powerful intercity express of all time. With 830 seats, this train is meant to be the new backbone of long-distance rail transport in Germany. Maintenance and repair take place here in Hamburg's Eidelstedt district. Mechanics, electronics, digital systems. Everything has been under special observation since trial operations began in October 2016. Fitters like Andreas Friedrich are specially trained to recognize the smallest problems and malfunctions in the new technology.
We're checking the suspension system now and have to look for damage, visible damage on the exterior like flat spots, oily shock absorbers and broken springs. This is the air suspension, which provides greater comfort than the metal springs used in the ICE-1.
Markus Peto works on Deutsche Bahn's flagship train. In the past, his job was called engineer. Today, he refers to himself as a driver. His cockpit is a cluster of computers. Without the most powerful and fastest computing capacity possible, nothing works in this giant of the rails.
This is really special for me. I've worked on the railroad for over 25 years. My father was also an engineer. In 1991, he drove the first ICE from the 401 series. And now, 25 years later, I sat here and drove the first ICE-4 from the new series.
All computers have been booted up.
Let them know we're ready to pull out.
It seems like a space station launch when Marcus Peto puts 13,500 horsepower in motion. Despite its power and size, the ICE-4 is about 120 tons lighter than the first ICE series.
It makes you proud when you sit at the controls and perform operations, and you understand how the technology works, how the tractive force is unleashed to make it up the mountains. It's simply awesome.
The ICE-4 contains several independent security mechanisms. They are active during the entire journey and monitor continuously the entire control system.
The systems on board support the driver. They take a lot of pressure off him, making it possible for him to take care of other things, like keeping an eye on the tracks. But in the end, it is me, the driver, who takes action, and the train does what I say.
The passengers are barely aware of the technology. Even in second class, they have comfortable seats and can store more luggage. For the first time, bicycles are also allowed on the ICE. With a reservation, 8 spots are available. Leather in first class, and something special for families in an otherwise no-nonsense environment. The true innovation of the ICE-4 lies underneath the passengers. The drive system. Michael Brom was one of the train's designers.
One of the cars with seats, where we are sitting now, is a locomotive that need not necessarily be at the head or the tail of the train, but rather somewhere in the middle. There are 6 locomotives hidden in this train. They are under the floors of the cars and no one notices them.
Aluminium is no longer used. Workers are back to bending and welding steel. It's easier to work with. Nevertheless, the body has not become heavier, but rather lighter. The secret lies in the fabrication of especially rigid moldings. The bogies are also 1/3 lighter than on earlier ICEs. It took 10 years for the new train to hit the tracks.
You feel a personal sense of achievement when the things you've long considered, worked on, and discussed in Excel tables and PowerPoint presentations suddenly become tangible, something you can touch, board, and ride. To see it every day and have it become normal for travelers to use.
On a trial run, the ICE-4 travels from Hamburg to Munich and back. The first stop is the terminus station, Hamburg-Altona. Here, driver Marcus Peto must walk from one end of the train to the other in order to continue the journey. Backwards, so to speak. This small effort is followed by a reward. Now he is allowed to go full throttle. The ICE's high speed of 250 kilometers an hour is deliberately lower than that of other high-speed trains, to achieve a better energy balance and because it is barely worth it to drive faster in a country as densely populated as Germany. Still, something can always happen. But Marcus Peto is not worried.
The train brakes automatically, so if I get sick, if I pass out, the train would immediately put on an emergency brake. It would stay on until the train stopped. Then the train would stand still while the employees from the back came up to see what was wrong, and then they'd deal with the situation.
By 2023, 119 new ICE-4s should be driving on German tracks. The total cost, 5.3 billion euros. It will only be profitable if millions of future travelers also get on board this ultimate vehicle. The MiG-29, a flying legend.
Yeah, great. This is the best aircraft, so...
A dreaded hunter of its day. Poland, Minsk Mazowiecki. The Polish Air Force has flown the legendary Soviet jet for a good 30 years. The MiG-29's characteristic design includes wings blended to the fuselage and leading-edge root extensions. A construction that facilitates high speeds as well as outstanding maneuverability at subsonic speeds. Its unique agility makes the MiG-29 nearly unbeatable in a dogfight. Today, trainer Rafał is taking his student Mikołaj on a training flight with a MiG-29, in which they will run through various aerial maneuvers. Before going up in the air, Mikołaj, the trainee pilot, must first practice in a simulator.
I am just at the beginning of my training, so for me it's not that complicated, but it's a bit difficult for me now, so I will do my best.
Today's training is about air policing, which means to identify unknown aircraft and to react in a flash. In the simulator, the trainers confront Mikołaj with situations that he will also have to deal with immediately once he gets up in the air. In the meantime, mechanics prepare the aircraft for the pilots. They check all the systems again. In an airplane made of 6 million individual parts, many things can go wrong. Thus, the MiGs come here regularly for maintenance. Martin is the head of the maintenance crew and is responsible for the squadron's total of 16 MiGs.
This plane is a legend now because in those years when this plane was appeared, it was, I think, absolutely the most powerful and most dangerous planes on over the world. His radio electronics elements, radio station, radar and the armament system, they're very, very advanced and sophisticated.
The MiG-29 went into serial production in 1982. In its early years, it was a dreaded unknown for the West. Only in 1988 at the Farnborough Air Show did representatives of NATO countries get a closer look at the MiG-29. They were amazed at its extraordinary aerial capabilities.
Now they are 27 years old. The Polish Air Force plans to use these planes during the next 13 years.
For agility and speed, the MiG-29 is still tough to beat. How to deploy these features ideally for air policing is what Rafał and Mikołaj will be practicing in a 45-minute training flight.
It's very fun. It has some capabilities that are unique for the aircraft, like aerodynamics and thrust-to-weight ratio. And it's sometimes very difficult, so you have to be on your feet. Sorry.
During the exterior inspection, Rafał also checks the huge air intakes. For takeoff, they are automatically closed with flaps so that no dirt gets into the highly sensitive engines. Then air enters through intakes on the wings, a unique design. Rafał and Mikołaj start their jet's powerful engines and taxi slowly to the runway. In a real air policing mission, pilots must be in the air no later than 15 minutes after getting the alert. Like most Russian fighter jets, the MiG-29 has an especially robust undercarriage, so that it can also take off from provisional airstrips. Pilots need only 270 meters of runway for takeoff, and in less than a minute, they can reach an altitude of 10,000 meters. In relation to the aircraft's weight, The engines are so powerful that the MiG-29 can ascend vertically like a rocket, and it almost reaches the speed of sound in vertical flight. Speed and agility were always its obvious advantages. Disadvantages were the short range due to small tanks and the small range of its infrared targeting system. For the MiG-29 was originally designed only for short-range air defense. If pilots embroiled their adversary in a dogfight, they were almost invincible. After 3/4 of an hour, Rafał and Mikołaj return from their training flight. The plane lands at a speed of 250 kilometers an hour. Using air brakes and a brake chute, the MiG-29 only needs a runway 750 meters long. The air intakes are closed again for landing. Mikołaj has just finished a grueling training session. He had, of course, practiced the maneuvers in the simulator ahead of time. But it all feels very different at an altitude of over 10,000 meters and speeds near the sound barrier.
Yeah, that was fun. I hope I was better than in the simulator, yeah? But we will see.
What matters is the opinion of his trainer, Rafał.
We accomplished everything we briefed, so I'm happy about this. We have some minor stuff to discuss, but most of all was fine. So I'm happy for this flight.
And of course with his plane, the legendary MiG-29. No other model was produced more frequently, the T-54-55. Also in this episode, the most dreaded tank of the Second World War. And the ancestor of all modern airplanes, the DC-3, used in the Amazon basin. Great Britain, Bovington. This is home to the world's largest tank museum. The collection is unique. Over 300 armored combat vehicles are here. It is one of the most legendary tanks of World War II, a steel beast. Dreaded by its enemies, it is unique for its myth of invincibility, the German Tiger I. Curator and tank expert David Willey has the overview. For him, it is clear that the Tiger had above all strategic significance for the Germans.
Obviously, there was a fear factor because the tank was so big, so powerful, it could outrange pretty much any Allied tank when it first appears.
The steel Colossus is nearly 8.5 meters long, over 3.5 meters wide, and weighs 57 tons. That made it up to 20 tons heavier than all of its opponents on the battlefield. Up to 10 centimeters of steel made the tank nearly impenetrable to enemy fire. When introduced, it was the most powerful tank of its day. With a 700 horsepower V12 engine, the heavyweight could achieve a cross-country speed of 20 kilometers per hour. On paved roads, the Tiger could go twice as fast. But this was reflected in fuel consumption. Every 100 kilometers, the Tiger consumed about 540 liters of fuel. But its built-in weapons technology was also expensive. Many say too expensive. But it is precisely this technology that made the Tiger so special.
So the sighting arrangements, that in combination with that 88mm tremendously powerful gun, you're firing an armor-piercing round which can pretty much go through any known tank when this comes into service late 42, early 43.
The Tiger is a veritable sharpshooter. At a distance of up to 1,500 meters, it could destroy every target. On paper, the Tiger was superior to all other tanks. But too often the Tiger remained immobile due to technical problems.
And just quite simply, it was put together in a rush. So there was lots of teething troubles, lots of early mistakes, things breaking down. The gearbox was struggling, the engine to match that 56 tons. It was originally designed for 30 tons. So there's a series of issues they try and iron out during the production run.
The Tiger was its own worst enemy. Technical problems accumulated, and many of the heavyweights simply got stuck in Russia's difficult terrain. One of the tanks survived the war. It is now here in this museum. After months of inactivity, today it is supposed to drive again. If anyone knows every screw, every one of even the smallest of this 70-year-old tank's parts, then it is Mike Hayton.
We've got the only working one in the world, and it's a hard job to keep it in the condition that we like to keep it in. So it's always a challenge to me. All of these grey hairs on my head are due to the Tiger.
Also here today, Mike's team of mechanics. In addition, a fan is here to fulfill a lifelong dream, to drive a real Tiger. But will it start? There is barely room inside the tank for the 5 members of the crew. But Eric Schneider, the tank fan, is overwhelmed.
Well, it's really nice. It feels a little claustrophobic, but it's nice.
And sometimes the crew had to persevere inside the tank for days and weeks. To get the tank started, Mike first has the 2 heavy battery cells reinstalled. Then he attends to a special feature. This Tiger was deployed in Tunisia before being captured by British troops. To counter the hot and dusty conditions, this Tiger was equipped with a special filter.
It has what they call a FIFO air filtering system. So the system behind me filters the air before it gets to the engine air filters. And every time we lift the deck, we have to dismantle it so that we can get access.
Under the hood, a Maybach V12 is slumbering. But the 21-litre engine has its problems. Besides its tremendous fuel consumption, the engine's need for oil required the crew to make sure there were always enough reserves on board. This led to supply problems at the front. Mike checks the fuel level twice, just to make sure.
So we have this much fuel in the tank, so that's enough to run it today.
Now the preparations are complete, and the big moment approaches. The Tiger is going to drive. With every passing minute and every action of his crew, Mike Hayton's nervousness increases.
And we tried to take every precaution we can, and there's still the unknown. For example, last year we tried to start it for Tank Fest on the inertia starter, and it broke. So we had to take the engine out during the winter and repair that.
This could happen today too, of course. Under his direction, the mechanics pull the beast out of the hall. Now, ignition is only a few minutes away.
So, next one, turn the engine over a couple of times. We need the fuel turned on first.
Like an old propeller airplane, the Tiger can also be started mechanically.
Try again.
Only when there is enough oil pressure can the tank be started with a crank.
Wait, is that full choke? Should have gone by now. Yeah, try again, Darren. Oil pressure okay?
Finally, after months of standing still, the Tiger once again moves under its own power. Admittedly, somewhat hesitantly, but the chains are clattering slowly across the museum grounds. Only a small observation slit lets the driver see anything.
Yeah, change into 4th gear, Darren.
The beast that spread fear and panic on the battlefields of World War II moves forward slowly but surely. the 57 tons of steel creak with every movement. But Mike's meticulous work pays off, and the Tiger finally stands at its new location.
You know, for me it's always very stressful because, you know, we never want to break it, and so we try and do as much as we can to make sure we don't blow up.
The German Tiger 1 in Bovington is the only one that can still drive under its own power after more than 70 years. Colombia, Villavicencio. It is a legend.
The father of modern air travel.
The DC-3, a revolutionary plane that ushered in a new era of flying. And a good 70 years after it stopped being produced, it is still being used. The small city is about 100 kilometers away from the capital, Bogota. This is where the legendary airplane takes off and lands. More precisely, at La Vanguardia Airport. From here, the DC-3 regularly flies important aid supplies to the Amazon region, just about unreachable by car. The flight lasts 1 hour. The DC-3's great advantage: it can withstand mighty gusts and very heavy rainfall. According to myth, it can even land without a pilot. Be that as it may, Germán Romero sits in the cockpit every day. As pilot, he is also responsible for the entire cargo, and today for something special too.
There's a music festival at our destination. So, we're also taking a porta potty and many instruments for the musicians.
While cargo is being loaded at the tail, technicians check the front of the aged plane and refuel it. Everything manually and more or less according to feeling. There are no electric fuel gauges. No wonder, considering the aircraft's age.
The aircraft is 81 years old. And I've logged over 20,000 flight hours with it. I've been flying it for 38 years.
No mistakes are allowed during the inspections. Germán Romero has already made it through many dicey situations with the plane, and he has faith in it precisely because of its simple design.
In my view, it is the safest aircraft by far, in all kinds of weather, with incredible performance. The father of aviation.
More DC-3s have been produced than any other passenger airplane in history. In Colombia, it is an indispensable means of transportation. To maintain the plane's balance, the crew weighs every piece of baggage by hand to determine its place in the cargo hold. Loading is complete. Germán Romero moves into his living room, the cockpit. Computer and high-tech equipment are nowhere to be found. But that doesn't bother the experienced pilot. On the contrary.
This is an aircraft that is simply fun to fly. Many people are trained on it because you have to be able to fly with this aircraft.
The runway is clear for takeoff. The 8 tons of flying metal start moving. From this point on, it's all a matter of feeling and muscle strength. There are no hydraulic systems. In flight, the DC-3 is uncommonly easy to handle. Its design lets it fly very smoothly. This is thanks to what was at the time an innovation in aircraft construction. All this makes Germán Romero's work easier. Still, the classic plane doesn't fly itself.
Takeoff is the hardest part, but landing is the most dangerous.
Mechanics carry out daily maintenance to keep the DC-3 flying smoothly. In Colombia, this takes place not in an orderly hangar, but on the side of the runway under a blazing 40-degree sun. All under the watchful eye of Chief Mechanic Mario Parra. Spare parts are taken from old planes that are no longer fit to fly.
It's an old plane, but it's so well designed that it can fly with only one motor. As long as we maintain it, everything is fine.
The engine technology and wing design were revolutionary. And even today, the DC-3 is considered tough, flexible, easy to operate, and easy to maintain. All the parts are welded together with 500,000 rivets. The DC-3's history begins with supply problems at the competitor, Boeing. Trans World Airline needed airplanes and asked Douglas to design an aircraft. This was the birth of the DC-3 and thus of commercial air travel. Since it needed less fuel, flying became affordable. Structural shapes still in use today. Only the electrical systems and individual parts of more recent airplanes have been improved, and thankfully so.
Most of the DC-3's problems are the same as in other planes, but one crops up frequently. When it rains a lot and the engine gets wet, then the electrical system goes haywire as the old parts get moldy very quickly.
Problems not faced anymore by mechanics dealing with modern airplanes. Nevertheless, people in Villavicencio still keep on flying the DC-3, especially due to its ability to land on non-paved runways when flying to remote Amazonas regions. Like Germán Romero does. The flight to La Macarena lasts about 1 hour. A small onboard computer gives the pilot information about altitude and GPS position. When there is room, the plane also takes passengers. Being a pilot is a dream job for many people, including Germán Romero.
I always wanted to become a pilot, even as a young boy. And now I've been in the pilot seat since I was 18. It's the best.
The approach to La Macarena Airport, especially difficult due to extreme crosswinds and heavy gusts. But Germán Romero nails this landing too. Not perfectly, but safely and skillfully.
The flight was good, but we had really strong winds while landing. It wasn't easy, actually somewhat rough. Otherwise, perfect.
Another successful deployment for the DC-3 here in Colombia's Amazon basin. The over 80-year-old classic airplane has succeeded in bringing important goods to the remote location of La Macarena. And today's load also includes the porta potty for the upcoming music festival. Beneckenstein, Germany. For decades, they have been performing their task as the workhorse of armored corps all over the world. Tanks from the T-54, T-55 series. The T-55's theater of operations in Germany, today only in a museum. The museum has numerous military vehicles and tanks that can be booked for private rides. The biggest star among them, a T-55 from Poland. In Mario Tenzer and Marcel Koenig's tank driving school, this T-55 has found its final calling. For €300, enthusiasts can drive the tank for about half an hour. This once modern tank, however, is slowly showing its age.
It was built in 1972 and needs a lot of maintenance. It's an old lady continually beset by malfunctions.
Defekte begleiten das Fahrzeug ständig.
When the T-55 was chiefly used in the 1960s and 1970s, it was a modern weapon system. In order to buy the tank, however, Mario Tenzer had to remove all its weapons technology. The engine, on the other hand, is still original. Before Mario Tenzer can start the tank, he must preheat it. In order to go easy on the powerful but therefore sensitive engine, it had to be preheated even when it was used in combat conditions.
Of course, it's very special to drive with its 40-liter engine and its enormous power. It's quite a big deal.
Originally, the T-55 had a 4-man crew. Except for the seats for the driver and commander, however, everything has been removed from this model. The T-55 is so robust that even today, 70 years later, it continues to be used in local conflicts, especially in Africa. Mario Tenzer, however, is not very happy with his tank at the moment.
Did you see? It didn't turn. It turns poorly. There's oil everywhere. And it shifts poorly too.
With its unladen weight of 37 tons, the T-55 is a small and agile tank. This is what made it so beloved in its time. It is armed with a 100mm cannon, its rate of fire up to 7 shells per minute, its maximum range 2.5 kilometers. The tank driving school's terrain is no challenge for the T-55. It has a maximum gradability of 60% and can handle lateral slopes of 30%. In addition, it was the first tank to be able to cross waterways up to 4.5 meters deep. After 15 minutes, Mario Tenzer and Marcel Koenig have completed their test drive. But they do not look at all pleased.
During this short test drive, I got 2 blisters just from shifting, since the gears are so unsynchronized. And in one bend, we simply went straight, which means that sometimes we have hydraulic pressure and sometimes we don't.
Inspecting the engine for problems.
Here it's all oily. A somewhat bigger repair job. Oil is shooting out of the side of the engine's fan propeller. You can see it really well here. This part is covered in oil, as you can see on my finger.
Back in the workshop. Under the hood is a feat of engineering, exemplified by the sideways mounted engine. Extremely innovative for the time. It created more space for crew and cargo.
A lot was packed into a small space here. It's very tight. You have to turn 1,000 corners in order to get to a place where you need to make a repair.
The tank's impressive age makes things more difficult. Most of the tanks were built here, at the Chelyabinsk tractor plant, today Uralvagonzavod, one of the world's largest tank manufacturers. Nikolai Molodnyakov is one of the engineers who designed the T-55.
Western countries didn't stop producing tanks after World War II. Hence the great effort here to design a next-generation tank that would set new standards in every way.
The T-55 made its first public appearance in 1958 at the annual Victory Day Parade in Moscow. In contrast to its predecessor, the T-54, the T-55 has better armor, a stronger engine, a wider range of fire, infrared aiming, and it was one of the first tanks ever to have an automatic nuclear weapon protection system.
One of the requirements for this tank, and this was the mentality of the time, was that the crew had to be able to repair it right there on the battlefield. The engineers made this possible. And that's why the T-55 is so long-lived and is still being used today.
In the following decades, the T-55 has proven itself in several military conflicts all over the world, among others in Vietnam and Afghanistan. Thanks to its simple basic design, it was very easy to take apart and repair. Only one thing is necessary: strength. Some of the thickly armored plates weigh several hundred kilograms. In Beneckenstein, Mario Tenzer and Marcel Koenig searched for the problem in their malfunctioning T-55, originally built in 1972.
Look there, it's dripping.
A small leak in the hose can bring even the most produced tank in the world to its knees.
It's not so bad. It's not the hydraulic reservoir like we initially thought, but rather the hose behind it. We can see it now that we've taken it apart. It's a piece of cake to repair.
Ultimately, no tank was in use more frequently than the T-54-55. In this episode, an airplane for $70,000, an hour, the first Boeing 787 designed as a business jet. Once, this was the fastest and most expensive private yacht at sea. The oldest cruise ship in the world is already almost a century old. Also, a luxury hotel on rails. The Japanese Shikishima brings exclusivity to a new level. Everett, near Seattle, in the US. This is the home of Boeing's main plant, where the 787 Dreamjet comes from. This so-called Dreamjet is the first 787 business jet, and at the same time, one of the most luxurious business jets in the world. Charles Coburn is Director of Marketing and sees to the exclusive clients who want to buy a 787. In his view, one of the best airplanes for a private jet.
It's the only airplane that is all composite. That lets you do so much. You know, increasing the humidity so you don't have to worry about corrosion 10, 20 years down the line.
The Dreamliner is about 20% lighter than an aircraft of comparable size.
Range is essential for a business jet. The 787 BBJ has the capability to fly nearly 10,000 nautical miles, which means you can go non-stop anywhere in the world that you want to.
For example, from China to the US, the home airport for this 787 is Haikou, on the island of Hainan in southern China. This 224 square meter plane provides space for 380 people on commercial flights. The rent for the business model is $70,000 per hour. Jessie Mi Shanpan is the 787's cabin chief. She makes sure that its upscale passengers want for nothing.
We just received a trip request from the owner, and he wants to fly to the States, so it's going to be a long-haul operation for us, a lot of work, but we'll have to make sure the cabin's ready and it's perfect for him to fly later on.
Today, for the first time ever, a film crew is allowed to get a closer look at the exclusive luxury airplane. The first stop is the main cabin, which serves as a lounge and conference room. There is room for up to 16 people. Like normal airplane seats, the luxurious sofas and armchairs are outfitted with seatbelts and life jackets. In the back, there is place for 24 more passengers. The 18 first class and 6 business class seats are for the crew and the client's attendants. Here too, a premium was placed on appearance and luxury. The galley is located in the tail of the airplane. For safety reasons, it is a standard galley, like in every other 787-8. The front of the 787 contains private rooms for the main client. A bedroom as large as a whole apartment, including a king-size bed, and an adjoining luxury bathroom. Next to the bedroom, a narrow passage leads to the cockpit. Only a handful of pilots are allowed to fly this 787. In the main cabin, Jessie Mi-Shan-Pan and her team prepare everything for the upcoming flight. In less than 2 hours, the client will be there, and there is much to do.
We also need to test to see every seat are working. So we were doing the testing. This is good.
All the cabin electronics, like the adjustable sofa, multimedia devices, and the lights, can be controlled from a central unit. Jessie Mi-Shan-Pan and her team are preparing the bedroom for the client. In addition to exquisite materials like cashmere and satin, a 42-inch television awaits the client.
This bedroom, because of the material of the wall, and you can feel it, the texture. Yeah, because of these materials, it can keep the noise down to a very low level. Even when we're flying, it is under 48 dBs.
That corresponds to the noise level in a normal apartment.
We have different light scenario for the lighting that makes our job very easy. For example, we usually keep the bedroom lighting to relax.
The food for the long-haul flight is being delivered.
Sometimes they want McDonald's or Kentucky, but this time he wants catering from this hotel.
After the choice food, which must be paid for separately, is stowed in the warming cabinets, the cabin chief begins her final inspection.
At the end of the check, we usually sit in here on his eye level, and we might be able to pick up something wrong. It looks everything good now, finally, and we actually have not enough time today, but I think we're able to make everything perfect, and we'll wait for the client to board now.
In only 2 hours, Jessie Mi-Shan-Pan and her team have prepared the 787's 224 square meters according to the client's wishes, down to the last detail. Now, the client can come. The Caribbean, Trinidad-Tobago, Man O' War Bay. She is one of the last of her kind, and despite her age, still one of the biggest and fastest sailing ships of her class. In 1931, the Sea Cloud was launched under the name Hussar, around 110 meters long, outfitted with 30 sails. Then as now, she is absolutely uncomparable. Commissioned by an American millionaire, the Sea Cloud was at the time the most expensive private yacht in the world. Today, she is a luxury cruise ship with capacity for 60 passengers. The Sea Cloud lies at anchor in the bay of the tropical island. Today's destination, the island of Grenada, about 100 kilometers away. The Russian Vladimir Pushkarev has guided the ship across the 7 seas since 2009, and with 1931 technology.
We don't have a pitch control of propellers. We use an old telegraph, old way of maneuvering. So, kind of classic, old school.
The entire hull and a large part of the superstructure are still original to the 1930s. Sometimes the technology goes haywire, like the capstan right now.
Modern ships, they have hydraulic winches, they have hydraulic brakes, and all push-button controls over there using muscles.
After some loving maintenance, the winch works again, and the Sea Cloud can finally set off.
Okay, anchor home.
Although the Sea Cloud is a sailing ship, it uses engine power to reach the open sea. The winds in the bay are simply too weak.
300, please.
300. 2 ahead slow.
The signal goes from the bridge right to the engine room. Here the steerage is also the same as nearly 90 years ago. Only the two 772 kilowatt diesel engines are new. They can bring the Sea Cloud to a speed of up to 10.5 knots. The combination of modern engine drive and sails made the Sea Cloud the fastest ship of its day. Today, the crew consists of about 60 people, the same as the number of guests. To set 30 sails, plenty of manpower is needed.
We are bracing opposite tack. Call crew, stand by.
Roger, opposite, bracing.
Everything here is done with pure muscle power. The only small bit of help comes from electric winches, which help to turn the yards into the wind. It takes more than an hour to set the sails on the 4 masts. They give the Sea Cloud an impressive total of 3,000 square meters of sail area. The sails must be changed every 5 to 7 years. Gdansk, Poland, is home to one of the largest sail makers in Europe. The workers here make the sails for the Sea Cloud by hand, as large as 200 square meters and weighing up to 100 kilograms. Captain Adam Pascho was previously the Sea Cloud's first officer, and today he is responsible for its maintenance. No one knows the ship as well as he.
In the 1930s, this was the biggest, the best yacht, private yacht you can build. Everything what you can get on the market in those days was placed on the yacht. The best whatever you can build in the world.
The 10 original cabins, such as this one, have been preserved intact. Where cruise ship guests stay today, heads of state, Hollywood stars and captains of industry slept nearly 90 years ago. At the end of the 1970s, it was ultimately brought to Germany and converted into a cruise ship.
The future of the Sea Cloud is quite clear. I would say as long as we can keep her safety standard on the highest level, and as long as we can keep her maintained to provide this safety environment for the passengers, for the crew, that she can be seaworthy, that long she's supposed to sail.
In the Caribbean, the Sea Cloud has nearly reached her destination. But the real challenge is about to come.
We have to go inside of the old harbor, St. George's Old Harbor. There are shallows all over here, 5 meters, 6 meters shallow waters. This is the size of the ship. That's how we will go, and then approach, then stop, then turn. Yeah, no, of course, the challenge, do not hit the dock.
To this end, the crew must gather the sails. Only then can the Sea Cloud be maneuvered into the narrow harbor. The harbor pilot comes aboard to help. For the Sea Cloud is actually much too big for the small harbor. The channel is only a bit wider than the ship. The mood is tense. A few meters too far to the right or left, and the Sea Cloud will run aground in the shallow harbor.
All stop! 2 back slow!
After nearly an hour, the job is done. Vladimir Pushkarev is relieved.
She's a nice ship. She's really something. I feel myself privileged to sail on this ship and to be a captain. It's a dream.
And in only a few hours, the Sea Cloud will depart for its next destination. Tokyo, Japan's capital. Today, the Shikishima will undertake one of its first test drives. A 5-star hotel in a cramped space, the showpiece of the Japanese railway company JR East. Pure luxury for the guests and hard work for the employees. It took 6 years to build the train. The development costs about $80 million. For the general manager, Michiko Ozawa, it is a milestone in the history of train travel.
In the past, trains were only used to get from one place to another. But the novel concept of this train is to enjoy the ride. It's not about speed anymore, but rather the experience itself. Like on a cruise ship, we also make stops and show the passengers the special features of each region.
Shikishima means 4 seasons. And indeed, the luxury train's routes vary by season. The goal, to always present the most beautiful side of Japan.
The challenge was to assemble the team. The design was developed by Ken Okuyama. Great attention was paid to every detail of the interior design. For example, the wood is a special Japanese wood. The whole team worked very hard. Onboard service was also very important. We have a first-class chef.
This exclusivity has its price. Tickets cost between $2,800 and $10,000 US. The Shikishima has 10 cars. 6 of them have sleeper suites for the guests. The journey begins at the station in Ueno, a district in central Tokyo. The guests can relax in the newly built lounge. A total of 12 service personnel take care of the passengers. Kayo Tamura is one of them. This journey counts as a dress rehearsal for her.
I'm definitely nervous, but this is still only a training exercise, and I'm really looking forward to working on this train.
As the luxury train pulls in, a wave of excitement mounts. Today's guests consist of high-ranking employees of the railway company, journalists, and actresses. A lottery decides who gets a ticket. A concierge brings each passenger individually to his or her room. A maximum of 34 guests can travel on the luxury train. "15 standard double rooms all have their own separate bathroom, even including a shower. 11:40, departure. The driver sits at the head of the train, separated from the passengers only by a pane of glass. The longest route takes passengers all the way to the northern island of Hokkaido and lasts 4 days. While the guests relax, steward Kayo Tamura does an inspection round. In the observation car, the passengers can watch Japan's landscape pass by. That's why the train only travels at a maximum speed of 100 kilometers per hour.
I was excited the first time I boarded the train. It's so luxurious. Every little detail was carefully chosen, every plate designed specially for the train, and everything comes from the regions we drive through. That really thrills me.
It's time to get things ready for dinner. A 5-course meal awaits the passengers in the dining car.
The challenge of my job is that I not only work as a restaurant professional, but I must also be good in every other area, like mixing cocktails or making beds. If you work in a normal hotel, you only have one job. But on this train, I have to do everything, and it's difficult to do everything perfectly.
In the kitchen, a team of 6 people sees to the guests' gastronomic pleasure. The cramped space and the train's constant movements make cooking a true challenge for head chef Iwasaki Hitoshi.
The menu was specially tailored to the conditions here on board. The train moves, and so to keep everything from falling off the plate, I've made a thick sauce. I spread it on the plate and place the food on top.
A rolling 5-star hotel. For train hostess Kayo Tamura, today's journey is only the 2nd time she has worked on the Shikishima.
This is my cheat sheet. I haven't been doing the job for very long, so I wrote down exactly what the dishes are called and what they contain.
While the guests wallow in luxury up above, Kayo Tamura shows us the break room for the service personnel.
There's not much space, and it's very hot and humid. Honestly, it's not that nice to eat here, but we have to do it this way for the customers. It's okay though.
Everything for the good of the guests. After dinner, there is entertainment at the bar. In the meantime, Kayo Tamura takes care of the next task, making up one of the 2 deluxe suites. The young steward makes the beds under the watchful eye of a trainer. For 3 nights in this deluxe room, guests pay about $8,000 US. In addition to a fireplace, the amenities even include a bathtub made of the finest cypress wood.
The customers pay lots of money to travel on this train, so they expect a very high standard of service. I feel like I have to do everything perfectly.
This luxuriousness is outdone only by the next room. A trip in the 2-level suite costs another $1,000 on top.
I've been working here for 3 months, and I want to do my best, satisfy the customers, and make them happy. I can't imagine doing anything else. I really like this job a lot.
After 10 hours, Kayo Tamura's shift comes to an end. And while the guests sleep at night, the luxury train takes them to a new destination.